All right. Well, welcome everyone to another FZ webinar. My name is Jake Haub, I'm the manufacturing millennial and a business development here at Fine Zelstra. And today we're going to be talking about a really fun, but not so fun topic, talking about the skeletons in our closet and the mistakes we've made in the industry. But I think it's always good to know what mistakes we've made and then how we've learned from them. So joining me on this panel is several people who have had years of experience. We have David Deaton. He's a principal engineer in our Carolina region. Kyle Reisner, he is the director of customer success and solutions here at Fine Zelstra. And Keith Rollenhagen, he is our practice leader and controls and automation. So thank you guys all for joining us today.
Great stuff. Always here to love to share the mistakes we made.
Absolutely. So I'm going to go ahead and kick us off with just a fun question. I always like to do a little bit of crowd breakers. So let's go ahead and run with what is your favorite caffeinated beverage of choice? Who wants to kick us off with that? Keith, what's your favorite caffeinated beverage of choice?
I'd have to go with Coke Zero.
Coke Zero. Now, does it really taste like Coke?
No, it's not near as good as the real Coke, but
it's manageable.
I can't have the sugar. So,
Kyle, what about you?
I like nitro cold brews from Starbucks.
Okay.
So I don't know what the nitrogen does, but it does something, and it's awesome.
It makes your drink $7. That's what it does. And David, what about you? Your favorite caffeinated beverage?
It's got to be the Pilot Station coffee, the French vanilla flavored.
Nice. Very good. I mean, for me, my cheat is Mountain Dew is probably my soda of choice. If not, straight black coffee is what I like to roll to for caffeinated beverages. But we're going to go ahead and let's talk, let's talk about our mistakes and we'll kind of roll into that. So let's go ahead and, Keith, let's roll with you. You've been in the industry for a long time. You've worked up from just, basic controls engineering to running a team. And now the position you're at now, what are some things that you've learned along the way with your mistakes? And I know you got a great thing to kick it off with.
Well, as a lot of people know, we're controls engineers. We don't make mistakes. They're usually a mechanical mistake, or the salesman sold something that's not positive or possible. So controls engineers don't make mistakes, right?
No, never.
But no, in all seriousness, it's we make lots of mistakes along the way. I remember one where not knowing the proper connector on the hardware. Slick 500 uses RJ45 port, and you think it's Ethernet. It's actually DH45. And if you plug in an Ethernet cable to that in your computer, it blows the power supply. And we went in to make a simple adjustment to an alarm and add an alarm, and we had an entire shift of downtime because fried the power supply, had to get another power supply, get it in. And so a little 5-minute programming change was an entire shift of lost production.
Yep.
So you need to know what you're connecting to and the correct communication cables and protocols to make sure you're doing it the right way with the right tools.
Absolutely. Kyle, what about you? We'll kick it around the group a little bit. What are some mistakes that you've been all over the place with different companies and different stages of your careers. What's some great, mistakes that you've made that you've learned from over the years?
Yeah, I think there's a couple that come to mind, particularly in controls engineering realm, but also information side. I think earlier in my career, and you only realize this stuff when you start looking back in your time, is my company I worked for was approached for just getting essentially an engineer for Siemens programming, and they had purchased an old booking press, and they needed someone to come in and get it running. And when you're like the last engineering company to call and you have someone available, that happened to be me. I was told, hey, 50 miles from here, there's a plant, and they got an old press, and they just give a purchase order for about, I don't know, about 3 months worth of work.
Mhm.
So I was young and adventurous, and I show up with a bunch of Siemens discs. Back in those days, I had to carry a little accordion for all the CDs they had. Some of them had, I had a couple of floppies and an external floppy drive, and actually, I think the laptop at the time actually had a floppy drive still. And I was way over my head. My boss at the time didn't really connect me with the right people internally to mentor me. Arguably, the budget didn't allow for any additional engineers to be on the project, and the rates were sort of a fire sale because I was available. And I worked on that press for about 3 months. And what I didn't do is I didn't first map out the process of the sequence of the press. I instantly went into trying to trace wires and sort of do all the things that a young person would do, right? Work backwards from sensors and not look at the program. And there was a program in the actual Siemens controller in there. But simple things like what is the end game of the press to run? Does this cylinder go? Subsequently years later, I learned what a sequence diagram was and how important that was, and how important it was to maybe start at the print level and then work backwards. Don't just dive into that. So at the end of it, also as a disclaimer, the press had on the side of it West Germany, so it was quite dated, and it was built with in my opinion, a little bit different philosophy than pretty much every other machine I've seen. But yeah, I spent 3 months on that, and I ultimately did not get it to cycle fully. It would do a manual cycle, and that was the best we could do. And the customer pulled the plug. And ultimately, I don't really know what happened to the project, but speccing it out, understanding the process first, not diving into the controls, as well as advising the customer that we need materials, because trying to clean out an old encoder or to utilize some type of measurement system on where the distances was, it'd just be better if you modernize that. So
yeah,
I'll
absolutely.
tell that story to too many people, but I'll tell it publicly here. But I think it's a couple important lessons that
if a machine's dated West Germany, you should probably evaluate it a little bit better. That's a great cue.
Yeah.
David, what about you?
I think it's good we're going through this because in our industry the risks are higher, safety risks are higher, equipment costs are higher, production costs are higher. So everybody makes mistakes at work, but man, ours are amplified many times in a lot of cases. And I guess the biggest one in my career had to be on Disney Cruise Lines. We were working on upgrading the safety fire spill systems. Upgrade all their PLCs, enhance their capabilities, allow them to respond to fires quicker. And this is a big deal. This is they don't stop the ships. There's 3,000, 4,000 people on each ship, and the upgrade was not stopping progress. So there was risk assessment after risk assessment.
Are you doing these upgrades while the cruise ship is going?
Oh yeah, yeah.
So you're on a cruise ship out to sea doing upgrades.
We boarded with the rest of the crew. I get some ice cream with Mickey on the way out and go see a show. And Monday morning, next morning, get to work. And Disney takes this stuff seriously. They're a great company, and they care about their guests. And they would actually station something like 25 people in an area 24 hours a day while we're doing the upgrade. In the event of there being some sort of fire disaster in that area, they could have a on-tap human response. So they operating theme parks, cruise ships, they know risk, and they were very serious about it, and so were we. And the project was going great. I mean, do all these risk assessments, do all this planning, it was rolling. And I think that's where the mistake started, was you go great for months. And we were doing a particular shutdown test, the test we were doing where we wanted to, in the event of a fiery spill in the main engine room, we would shut it down and ride only on the aft engine room. And this was a biggie. Everybody was on point for this because we wanted to make sure that we shut everything down properly and we could bring it back up. But luckily, there's a whole nother engine room that is completely separate physically from the engine room. So that had been gone through in the original risk assessment for this test. So we went and everybody's ready, and I clicked the button and everything went dark. Bow to stern. Elevators shut down, everybody, kids in the elevators. I do believe it was the Toy Story musical that was in progress at the time. The people were disembarking to go on adventures. It went black. And it was dead silent for a moment because I think everybody was pretty shocked. And I'll never forget, I said, huh. And it was the only noise that reverberated through the engine room. And that just kicked everybody into motion, and emergency generators started coming online and bringing it back. But, we were immediately in front of the captain, chief engineer, and began a after action trying to figure out what's going wrong. And turns out that if you're familiar with GE PLCs, you don't have to energize an entire rung to energize a coil in a FANUC PLC. You just have to energize the thing in front of the coil. And if you, let's say, duplicate the timer when you copy the logic from the aft engine room to the forward engine room and forget to rename the timer, you activate them simultaneously, bringing down every engine on the ship at the same time. So it's a study in complacency and one dude doing the logic without somebody else checking it, with riding high on past successes, and it was a hard fall.
Wow. That was, Keith and Kyle, sorry guys, David kind of ran with that one. Some of the learning experiences that, I have, I think is, in the business development side, robotic installations was a big thing for me, and really understanding the value that goes into reach studies when you're doing robotic systems. How much you have to look at, where it's not just a robotic application, it's the end of arm tooling, it's the reach study, it's the cycle time, it's the payload, it's the moment. And I think for me, there's projects that out there over the years that I've looked at quoting where you've underestimated the resources and the investment that go into setting up a system. So that was a big one for me. I think as well, within the business development side, when I was first doing, proposals, you customers bring you in and they say, oh, we have all these, projects we want to automate, we want to quote, we want to modernize. And you do all this investment, you spend, hours and hours of your time putting together a proposal and hours of your engineering time to put together proposals. And then you find out the guy you were talking to has absolutely zero influence or buying power. And I think that was a big thing for me within business development that I learned from, is find out who is actually the person who's making the capital approval, who's making the decisions on modernization and on automation, because there's a lot of people in the world that can say no. There's only a few people in the world that can say yes when it comes to moving projects forward. And if you don't have those people identified and who are the people who actually can say yes on projects, there's a lot of time and investment you can put into things that are going to have absolutely zero return on the time invested or lead to a future project.
I think that's a good one for end users to understand too. Our customers, there's a lot of engineers that approach FC and other integrators, and they have ideas, and they, what they're doing, if they don't have that figured out on their side, is that from an integrator's perspective, we're investing time, effort, in a lot of cases, pre-engineering up front, just to find out that the project is not a real project. And in the spirit of partnership, that's, a lot of our customers look at us as partners. And I think that's in the spirit of partnership for end users that are listening to that story, Jake, is for them to be cognizant of that, because ultimately the more we're providing a service, a needed service for, lots of companies hire out engineering integration because they just doesn't make sense for having it in-house, and you want a competitive landscape and all that other wonderful stuff, but you don't want to drag people along without that in place, without a clear line of sight to your project approvals and funding, because ultimately it hurts your relationship publicly with other companies. And there's cases where we won't do business with certain individuals, no matter what company they're at, because they just drag us along for a long time, right?
Yeah, absolutely. Keith,
Yeah.
David, any other stories that you guys have, mistakes that you've learned that you want to address, or what you've learned from them? I know Keith has very few with, being in controls engineering. There's not many mistakes that are made.
Yeah. Another one that I wanted to bring up was just, schedules. Controls engineers are always at the tail end of the schedule. Design takes long. A lot, getting the purchase order takes long. The end date still stays the same. So compressed schedule for controls engineers. There's another one where we had to start the programming on a job where mechanical designs weren't done, electrical designs weren't done, but we knew we had to start the program because it's due in 12 weeks. Has to ship in 12 weeks. With all of those unknowns, there wasn't a detailed functional spec of what the machine even had to do other than it has to make this widget. And so we wasted, we jumped in gung ho, started banging out code, and a week later, we 3 guys banging out code. A week later, what are we doing? We don't really know, but we're coding. We're getting the program done. We're scratching off the things on the list, and we wasted weeks of program time doing that because we had to rework about 90% of the program to because of all the things that changed or they weren't known, additions that nobody knew about. So just a big learning thing there was plan things out. Don't just jump in and start going when you don't know where you're going.
Yeah,
That
absolutely.
reminds me, I'll piggyback on that one. I spent a summer in college up in a remote town at a OSB mill. And, I personally reprogrammed the thing 3 times over that summer because we didn't start with the end in mind.
Yeah.
And I think that's something that, not just, seasoned engineers might get pressed into that situation by the machine builder or end customer, but I think it's important for, people that have the experience to say, hey, I'm actually not going to code this week. I'm not going to program this stuff. I'm going to take a step back and let's run through the operation and logically go through it rather than just dive in, and makes your code more organized. It makes the documentation more complete. One of the byproducts of that is I started working contracting. We have won projects for a Ford plant, which subsequently got sold off to a company called MEMAC. It was a casting plant. And the engineers in that plant mandated these project binders, and each project binder for each integrator required process overview, sequence diagram, documentation, or they would not essentially pay you the last, X% on your project. So that sort of forced a behavior when I went in to do projects for them of what are my screens going to look like? And we're going to design this out before you actually use the tool, right? Here's the previous sequence diagram. Where are we changing? What's the deviations? And then you sort of know what function blocks in the controller to go actually attack. So it makes you more efficient. So I think the common theme between Keith and my story is you sort of learn this, gunslinging problem solving is something that engineers and maintenance staff and tradespeople do very well. But what, as you evolve in your career and, get stung on a number of those things, get pulled into a 24-hour shift or have some plant manager breathe down your neck because Get Mechanical gave it to you on a Sunday night and it's got to be running on a Monday morning, to pre-plan and to spend the time to understand and bring the team through that. Because if controls people don't do it, you're just going to get handed it at the last minute.
Why is there always enough time, or there's never enough time to do it right, but there's always enough time to do it over?
Yeah.
Well, ego can play a big role in all that too. It's hard sometimes to, admit that you don't know, because a lot of times, we need to be confident in front of our customers. Don't pretend like you know something, but there's nothing that will get a customer more concerned than a look of panic on their controls engineer's face. So whether you're figuring out a problem or not, you try to stay cool and collected for all involved, but you got to watch the ego side of it. I know that I made quite a doozy with a lumber mill when I did not want to admit that I had no idea how to operate it. I wanted, there was an IO check. There was a procedure for the IO check. I didn't write the procedure, but I thought I'll follow the IO check and figure this thing out by the time I'm done. And that way I won't have to admit I don't know how the plant runs. And first first thing on there was checking the VFDs, checking the motor. So I bumped the 500 horsepower wood hog there and heard a terrible, awful noise. Turns out on the IO check procedure, the metal detector was pretty far down the list, and there was all sorts of chain and structure on the conveyor that I had IO checked right before the wood hog, and destroyed the motor, destroyed the hog, and all because the IO check procedure was in the wrong order. But I didn't write the procedure, but I followed it. And I didn't know how the system worked. And changes were made, and we weren't necessarily blamed at the time. But as an engineer, if you're going to use that title, use that name, you take responsibility for the system, and you got to put the ego to the side. It's hard sometimes.
Yeah,
I think another one from a learning experience, and this is not necessarily related to control side, is on large scale projects, it's extremely important to be sure. And today's with material shortages and control shortages, making sure you're staying up to date with your vendors on product deliveries, even if you're still a month out, 2 months out on a lot of projects, for being delivered, to constantly stay in touch with the vendors on stuff, because I think a lot of people are going to find out really quickly where delivery dates are have not been met and will continue not to be met for a long time. And I think it's very important for the purchasing side, but also the people who are from the project management side, to make sure things are going forward and stay on top of those things. And I think, we can do our best to address those, but we got to make sure we're keeping our vendors accountable as well from that perspective.
For sure. Aligning those delivery times with, like Keith said earlier, mechanical deliveries. Ultimately control systems are part of bigger automation systems, and there's a lot of variables that go into robot delivery or guarding or steel or aluminum pieces and that kind of stuff. So, aligning those delivery times with, like, why start doing mechanical build when it's going to sit there for 4 months because you're waiting on drives to come in, right? Mm-hmm. So I think it's a real problem in this COVID times, call it COVID times, or supply chain chip problems, whatever derivative you want to talk about, right? So
absolutely.
I think one other item that comes to mind is on the information solutions side. I've had some teams that I've ran over the years where I had this a good friend of mine who did a SCADA system up in Vermont, and one of the things that he really wasn't that versed in SCADA systems or HMIs in general, was just mainly panel views and that such. But the project called for a more complicated tracking and control data acquisition system. So one of the things that he did was, just add all the tags at the highest scan rate into the SCADA system and hit the controller. And at that time, the controller really doesn't, and a lot of controllers out there, they don't have protection against that bogging down the scan time of the CPU. And a lot of those services are shared with the actual PLC code running. Now, some multi-core systems now have separate chipsets that do that, but him troubleshooting why the screen wasn't updating, and I'm like, you have 15,000 tags being scanned on exception, right? Like there's certain things in that case, if you're timing anything in the controller, or you're have any type of logic that needs updating, say PID loops or something like that, you can affect the control of the process through basically requesting too much information. Now, some controllers, particularly on the Rockwell side, the newer ones, they do have protection against this, but the older stuff, I remember when I was at Rockwell, the drive systems, accessing drive systems via Ethernet, you can fault the drive by requesting it too much, because the backend architecture actually is an Ethernet. It's a converter that converts to some serial protocol. And it was designed for like a little panel on the actual device, and you're taking these taking these and hitting them with like, I want data every millisecond. And I see some things posted over LinkedIn and other venues where people are building Adrenos and building these small computers to hit industrial control systems. And I always cringe them when I see some of that, because if they're not designed to pub sub massively to million of clients, right? So just encourage everyone. I've seen it personally happen. I did a track and trace application down in Cincinnati for an automotive company, and yeah, we had to throttle back and send up arrays and then parse it at the high end, because it was less calls into the controller and subsequently on the network. So for what it's worth, I think people should be cognizant of that. These systems are not modern IoT systems that can have 50 streams of data going to 50 different spots. So
yeah, absolutely.
So if I put myself in the spot of the customer, the manufacturing the maintenance manager, and I've logged onto this thing, and now I'm scared to death let anybody touch my system. How do I protect myself? What steps can be taken on the end user, the customer side, when they see this controls engineer stepping onto their plant floor?
yeah, I think it's a great point. I mean, I'll start. Maybe Keith can continue. I think looking at some type of standards, especially when a new vendor comes into your plant on, hey, this is the way I expect things documented, and enforcing a design phase up front can really help. Sort of steer the ship in the right direction. And I've been in plants where it's you sort of earn your way to be able to troubleshoot the systems and even plug into the control system networks. And a lot of that is built through, enforced through standards and check boxes, but a lot of it also is just simply working with an assigned person inside the plant. So don't totally outsource all your controls engineering. Maybe that controls engineer inside your plant is more of a project facilitator than a controls engineer, but that background can save you. Keith, you want to add anything?
Yeah, I was going to say, the standard, you touched on it, Kyle, but this standardization on things and having people there that know your own standards. And so when one of our controls engineers comes in, they can work with somebody there until they learn your systems enough to not be dangerous. Even something as simple as, what software version are you on? We've had it where we've gone into a place with version 10 of the software, but the end user's version 9, we touched it, and now the end user can't access it anymore. Having that type of information and knowing that that's a problem from your side of things too helps as well.
And those risk assessments, I mean, that's there's never an inappropriate time to ask for a risk assessment, even if it's a simple one. It forces everybody to think to it. In some cases, it's as simple as somebody help me here. It's what they do on the electrical, the electrical side of things before they walk into a job site, a JROA, a job site. It's a small sheet they fill out on a daily basis before they walk onto their job site to identify hazards. They can be that simple on the control system side, or they can be a lot more complex and involve go a lot deeper depending on your application. The marine application, it slipped through the cracks, but I think that came down to not continually doing smaller risk assessments. And I mean, you start with what's the worst that can happen, and then determine your level of risk assessment based on the worst that can happen. Of course, we tend to have pretty active imaginations. You ask us what's the worst that can happen, you might ended up more nervous than you came in with. But yeah, I guess practically, what's the worst that can happen is the better answer.
Yeah, I think it's also important, as when you look at the duty of care that engineering professionals carry, I think, we have to, and really as we mentor younger folks, that we've all had skeletons in the closet, to reinforce that it's not about being super cautious when no work gets done. It's about, like David, you touched on this earlier, admitting where your gaps are, leaving your ego at the door, because we're all in this together, right? If I was at a plant where someone bypassed some safety equipment and a drop lift crushed them, I went to the plant that morning and told the plant is not running today because there's a death in the plant. And they had a bunch of engineering reviews, and like it was a really interesting experience going through that, because everyone is responsible for why could we have poked out the system better? Could we have, what could we have done to enhance the safety of the system? And I think that's something you sign up to when you are a controls person, whether you're a licensed engineer, whether you're a degreed engineer, or whether you're someone who's learned the craft and are applying themselves in our business. And I think that's something that a lot of people outside the business don't see. And we have to really drive that home to younger people or older people coming into this business, is that the mechanical folks tend to have things that are proven, that they tend to be, when you're moving something, it's A to B. It's the electrical distribution folks, it's pretty much they're not innovating. But in the controls arena, one wrong move in a David's situation on the cruise ship shuts down a whole cruise ship. But imagine if that was in a plant, like a nuclear plant, or imagine if that was a amusement park ride, or other processes that I've never had experience in, but like mixing chemicals. If that process stops or gets mixed wrong, you have a serious situation on your hands. So I always equate, when I was doing hands-on controls engineering, is you do a lot of stuff that can really hurt people if you do it wrong. And I think we have to be cognizant of that, and not to a point where we don't do work and we don't drive the industry forward and we don't innovate. But there is an element of that in this business, and we all have to be aware of it.
Well, control panels are built to, UL standards. Electrical distribution has NEC code. A lot of mechanical work, they have environments can be in, stress tests, heat limitations. I have consulted in a court case where somebody got killed by a laundry bag dropping down off of a rack when they replaced hardwire controls with a PLC because some of the logic was jumped out. And the question was, where are the legal standards that you have to abide by? And that particular state, and just in general, there are no standards. There's nothing codified. We pretend like it's new. It's not new, because PLC has been around for a long time, but it's becoming safety and what you can do with code, with software. There's more standards in general commercial software than there are in PLC logic. And there's more adhered to standards in something that you get off the Google Play Store, than what you go and put in the PLC from an industry-wide acceptance standpoint. And I'm not. Can anybody argue with that?
I think that's the beauty and the downfall. I mean, when you look at peer review code, when you look at what it takes to get stuff into the app stores and stuff like that, yeah, absolutely. I think and it speaks back to almost, I look at controls engineering as you go through an apprenticeship phase after you either go to school or after you're a tradesperson, and because you can't be thrown into this stuff. I was at that tooling company where make that press, and luckily that I didn't hurt myself and I think or anybody else, but I think there are certain things that you've just got to be cognizant of, and I don't think we mean to share all these stories to make people afraid about coming into our industry, because there's a lot of fun and there's a lot of innovation going on, and there's a lot of real hands-on stuff you can affect, or B, put the fear of God in people for touching these systems. But I think to Dave's point, I mean, there can be court cases, and can you be personally liable for it? Well, these companies like FC carry liability insurance for this reason. And I think good engineering practices avoids court cases and avoids safety situations and avoids people getting hurt. Ultimately, our job is to make the world more efficient, make manufacturing more efficient, make people more efficient. But we have to do it with the right level of care. Some of these skeletons are things that we've learned along the way, right?
I get to be the subject matter expert on engineering mistakes.
Oh, very good. Any other comments you guys want to wrap up, or any other stories that you guys want to share? Appreciate Keith, Kyle, David, you guys' time today on this.
Are we going to mistakes beyond the last 30 days? Because I was just doing last month.
Oh, okay. Well, we might have to set up another time for that one, David.
I think one of my last comments is I don't think we, as a community of controls focused and automation focused professionals, do share enough, so collectively. So, I mean, I think it's important to get these things out there. So whoever is watching or replaying the webinar here, I think people hire you for your experience, and that includes mistakes, right? And that includes hearing about other mistakes or being sat down in a factory where things have happened before, and you understanding tools that help eliminate those or at least mitigate them to the biggest extent. So I just want to say I encourage people to start to share, and whether that be reaching out to we're co-opetition, frenemy, like even your competitors who we all have a duty of care to serve in this capacity in society. And I think we should share more of this type stuff, and no matter how much your ego might get hurt, like David's. So
absolutely. Well, perfect. Thanks, guys, for hopping on. Of course, we have FC webinars every month. If you like to go back and listen to every other FC webinars, go visit findzelstra.com. And then, of course, we'll have these on our YouTube page and other social media as well. But until then, Keith, Kyle, David, we'll see you guys in the next one.
thanks, Jake.
Thanks, everyone. Bye.